imagine if you were an alien who, was visiting the Earth for the first time from some other galaxy. Imagine only visiting the United States and never visiting any other part of the Earth's surface. That's essentially what we've done with the Apollo missions, really been able to do wonderful and groundbreaking science with the samples, collected during the Apollo missions. But again, we visited only a very small part of the lunar surface.
The way that I think about it is it's the equivalent of landing on Earth and getting rocks from Kansas. It would give us insight into one particular location on the Earth, but not at all the diversity of what we see on the Earth, what we know is present on the Earth. So the ability to go to a different site, a different location, get different samples will just enrich what we have already learned from our Apollo samples.
There's a lot left to be learned about the moon, and it starts with the South Pole.
Okay, I'm gonna leave that 1 foot up there.
Artemis astronauts will fulfill a different mission in a unique environment. While the Apollo astronauts who visited the moon's surface between 1969 and 1972 landed near the equator, Artemis astronauts will venture to the moon's South Pole region, frigid, rugged, and with unique light and darkness conditions that make it an ideal location for exploration. The South Pole region is also home to the rim of the moon's largest, oldest, and deepest crater, called South Pole Aitken. It takes up almost a quarter of the moon, and is so deep it exposes portions of the moon's interior.
Yeah, the South Pole it's fascinating. There are some very unique types of rocks that are at the South Pole that will allow us to understand the entire history, not just of the moon, but potentially of the solar system.
Very early on in lunar history, we think that there was this increased period or very intense period of huge material hitting the surface of the moon, creating these really large craters or like giant holes, which we actually call basins. So getting a sample of impact melt from this basin would kind of help us bracket that early period of time.
The moon's South Pole region has resources that are vital for long-term exploration. Because the moon is barely tilted relative to the sun hovers over the horizon at the South Pole. Imagine a flashlight turned on, laying on a table. That's how the sun illuminates the South Pole. Light at the South Pole strikes at such a low angle, it brushes only areas of higher elevation, such as crater rims. These locations have sunlight for extended periods of time to harness for power. At the same time, the bottoms of some deep craters are shrouded in constant darkness. Scientists have measured the coldest temperatures in the solar system inside these craters, which have become known as perfect environments for preserving water for eons.
Over time, there's individual molecules of water and carbon dioxide and other gases that actually bounce around the surface of the moon. And when they get to one of these cold spots, they actually get stuck. So we call those places cold traps. And if you do that for millions and even billions of years, you can actually build up a pretty significant...
Conduct exploration for longer periods of time is going to be critical for Martian exploration, and lessons learned for that sustainable type of exploration start right here at the moon.
So there's still so much for us to learn from going back to the moon from a scientific perspective. It's a no-brainer in my head. So with Mars in the horizon as our kind of end goal, this is an important step for us to take. And then also just kind of from a human aspect, we all have this kind of intrinsic desire to explore. I think it's in all of us and certainly in us as a society. And so I think setting our sights on something and accomplishing this goal together is really important just for international relations, for, just coming together as a humankind, the human spirit. I think that's a piece of what we're doing that we can't ignore as well.
I have 3 kids, aged 10, 6, and 2. I talk about space often with them. The great thing that my parents did for me was let me find my path. I also look at my daughter, and I think, Okay, Amelia, she keeps saying she wants to be a firefighter, a construction worker, and an astronaut. And I said, well, Amelia, you can do all three and be an astronaut. Well, I mean, when you're an astronaut, you got to learn how to fight a fire in space. You got to learn how to build stuff. So you got to do all those things. What they'll become, I'm so excited to find out. I have no idea what they're gonna end up gravitating towards.
So why is the moon my favorite body to study? I think growing up, you could always see it in the sky. You could see some beautiful stars and maybe Mars or Jupiter as like small little dots, but the moon is just there in all its glory. It's like our nearest and dearest neighbor, and you can even with the naked eye, you could start picking out features on the moon. I think that was really cool. This is thousands of miles away, and you can still kind of be a geologist from the ground if you want to, and I think that's really cool, and that's why I always wanted to study the moon.